Hi, Graham from Condor. Just to follow up to our initial video on compressors and troubleshooting, which had thousands of views. Thanks very much for having a look at it. I hope my initial video helped many of you get well on the way to repairing your own compressor. So today we're going to follow up with a more in-depth look at how your compressor is working and how you would fix it and how to troubleshoot what your problems are. After the intro, we'll be back. The first component we're going to look at is the main part, which is that does all the compressing, which is the cylinder, the head and the piston. So we basically have a piston with rings, compression and oil rings. The oil ring is to control only the oil that's in the sump. There's no burning in here, so you don't have to worry about carbon build-up or that sort of stuff normally. Your cylinder, which your piston runs up and down inside of. Then your valve. This is the most important part. This is your valve plate. This particular one has a rubber O-ring for the head gasket and a top gasket. There are very few things that can go wrong with this valve plate. The valves themselves may not be seating either way, those two there, which will cause it to leak and not work. But the main issue with a lot of compressors is the gasket, and you can see this is here, it's broken. If air can get between the intake side and the exhaust side, it will pump up to, say, a pressure of 50 to 80 psi, and then it won't be able to turn off. It'll just keep going because it cannot get over that pressure, because there's more air going backwards forwards through there than what's going through the valves and being put out the outlet side. On your inlet side you have an air filter normally, and this is your component. Inlet side, outlet side has to be separated, and that gasket's an important part. Yeah, this port here goes down to your tank to store all your air that you're compressing. Okay, this is just a multiplier of that. This is a single cylinder, this is a two-cylinder pump. So this is a head gasket. It goes in between, then in the valve plate. So if it blows in between there, you will then be getting leakage and you will losing gasket. So the gasket can blow there. This particular compressor has 3 gaskets in it. So it has a head gasket, an intermediate gasket, and a top cover gasket. So they can also blow in between the intake and exhaust valve there, and that will cause it not to pump either. And another very common one, this one here, it will be blowing between the intake side and the exhaust or pressure side, and that will cause you the problems we're talking about. When your air flows out of your compressor, it comes down to a component which is bolted into your tank, which is a non-return valve. The job of the non-return valve is to let the air come into the tank and not come back out of the tank. So it has a valve in here. Most of them have a puck like situation, which is held in with a spring, or some don't have a spring, some sit upwards. There's many different configurations, so if you're ever after parts you really need to have a sample. What can happen, this surface area your surface area inside here can get marked, and that usually means you have to replace the whole thing. But more commonly is the surface area that seats up against that, it gets marks on it. Or sometimes the cap, these are tighter and they'll get caught in the cap. That one hasn't got a problem, but that's the 2 problems. If you just got marks on there, you can actually get on a bit of linishing sandpaper and that, and linish that back so it gets it smooth. That should get it going. And if it's jamming, if the outside is jamming inside the cap, you can take a bit off that with a bit of sandpaper as well. So the other job that the non-return valve does, it has an extra outlet. This extra outlet is for unloading of your compressor. Now what that means is when your compressor comes up to pressure, it now has 100 or 120 or 150 psi of pressure inside the tank. Now this pump has to try to start against that amount of pressure. You will find that it'll hum and carry on, it'll probably pop a thermal overload. So what this has, this other pipe here comes off your non-return valve and goes over to your pressure switch. This is your pressure switch. As you can see,
your direction of power is coming from this side to that side. So you would have, say, the 240 volts running in this side and your motor on that side. If you had a brown wire here, you'd have a brown wire off the motor from there. Blue wire here, you'd have a blue wire off the motor from there. This works by getting pressure. Runs a pressure switch, runs a diaphragm, and in the diaphragm it just pushes on the switch, joins those terminals together, and turns it off when it opens again. Another issue with these, they can break through there, so don't over tighten it, or you'll find that you will have a piece of aluminium and plastic which is no good to you. They will crack through here because they are tapered fitting.
So when it comes to pressure, it turns off. When it drops down on the differential, it then turns back on again. But at the same time as it turns off, what it does, there's a little valve in here. That valve is called the needle valve. When your compressor first starts, it has no air pressure in it. That valve will leak until it gets to about 20 pounds. That's the same issue, is it's trying to give that compressor time to start before there's pressure against it so that it's not going to overload the electric motor. So this leaks to about 20 psi. Once it hits 20 psi or so, it closes off that valve. Then the compressor will pump up to the pressure that you've set it at, and then it'll turn off. But when it turns off, it actually pushes that valve and opens that valve. What that valve then does, the air that's now in your delivery line here between your head and your tank is now able to be released, and it is released over here. So you'll have a piece of pipe running from here to here. It could be one end of the compressor to the other, so don't be fooled. If you hear air running out of there when you turn your compressor off, it could be that non-return valve leaking or stuck inside here. The other option can be is inside our pressure switch we have a diaphragm. What the diaphragm does, it sits on there, it's a rubber, made of rubber. They're not usually available as a spare part. So the air pressure comes up the pipe here, and it pushes on the diaphragm until it actually operates the switch, which has got an over, and so when it goes over, it flicks back. So the diaphragm could be worn. Now you can tell that's leaking or it's buggered because if it's got a hole in it or it's torn, as the compressor is running, you'll hear air running out of the side of your pressure switch, and that will indicate that there's a good chance that diaphragm is buggered. If air is running out of here somewhere, well, it's to do with the needle valve. This one's quite simple. It has a plus or a minus. Now if you want to increase the pressure, you put it onto the plus, and you decrease the pressure by moving on the minus. But there's only a small range, so you don't want to be moving that 10 or 20 turns. You're just turning a little bit, and you can get it up and down a little bit. Now these, normally what the other setting you get is that will set your top pressure where it turns off at. The other pressure you get is where it turns off at, which is the differential. Most of these ones don't have any setting for differential, so all you can do is set your top or bottom pressure, and it will drag the bottom pressure up with it. So if you set that at 100 psi and your differential is 30 pounds, that will be 170. If you then wind the top pressure up to 130, the bottom pressure now becomes 100 because it's 30-pound differential. Okay, this is a better quality switch. It's a Condor pressure switch. The difference between these is these ones have 2 springs and another one on adjuster. Now these ones are basically, if you tighten those down, that increases the pressure. If you loosen off, it decreases the pressure. You do that both at the same time though. So if you undo that one turn, you undo that one turn, and then you're increasing them both up and down evenly if you need to do that. If your spring is spinning like that, that will usually indicate the minimum differential is what you mostly want to have, which is about 30 psi. You can increase the differential, but that's not usually a common practice. 30 psi is usually where you want to run it, and you run in that sort of a range. And this one's got a push-in, push-fit fitting for your and when this one's running, idling, when this one is starting, you'll have air coming out of here until the valve closes. Once the valve closes, it will stay closed until it comes to the pressure, and as soon as it comes to the pressure, it'll go because you've now released the valve. The air will come out of that. Now if it keeps coming out, we're coming back to the non-return valve, and we've got to go and fix that first before we go any further. Hopefully that can give you a bit more of an insight into the actual internal workings and that of your compressor. Thanks for watching, and I'll keep your eye out for any new videos.